Okay. Yeah. First of all, I would want to thank the class for fixing this time for us to have the lecture. Unfortunately, I'm getting a little echo. I've logged in twice. Let me just. Yes, as I was saying earlier, thank you so much for coming for this class. I'm not going to take any attendance because it's a scheduled class. I'm happy you guys have been able to make it. Today, I think we have over 40 people who are here. So let's get started. So I'm Felix Aye. I'm going to take you for computer graphics. And I'm welcoming you for our first lecture, which is the introduction of computer graphics. So I'm going to introduce exactly what computer graphics is and what it particularly diverse and broad discipline. You know, it's quite big. We have CGIs and things all happening all incorporating computer graphics in the movie industry. We'll talk about some of these things as we move along. So I'll give you some sort of bit information about what the course will cover, and then we will do a quick overview of how our semester will be, how it's going to be structured, and how we plan to take through the computer graphics world. Afterwards, finally go through a little bit of information about the assignments that I'll be giving you in this course. So I have a question for the class. Please, I keep saying, let the class be interactive. So can anybody tell me what their expectations are or what his or her expectation is for the computer graphics class? Anyone, please. Hello? Okay, what now? What now? We are all ears. I think Joseph is also up. Oh, anyone, please. Just speak your mind. Nobody is going to beat you. There is no beating here. Just speak your mind. Hello? Are we in class? Are we here?
Yes, sir, we are here.
Yes, sir. Yes, sir. Can anybody tell me his or her expectation in a computer graphics class? Anyone? Oh, the guys, are you afraid of the girls? Anne and Xavier, why are you always together? Xavier, this time you talk. What is your expectation for the graphics class? Xavier? Xavier. So Xavier is not in class, but Anne is in class, right?
So she's here. Yeah, please, I'm here.
Ah, Xavier is a girl. Oh, okay. I thought Xavier is a boy. Oh, you can put your camera off, please. That's fine.
Okay.
Yes, so Anne or Cynthia, what's your expectation? Yes, okay, Kingsley, we have Kingsmon here. Kingsmon, enter. Enter.
Yeah.
Yes,
Hello.
yes, wonderful, yes.
So I expect that at the end of this course, that's
Yes.
the graphic course, I'll be able to use my computer or any other computer to create or manipulate images.
Oh, that's interesting. Okay, any other person? That's good. The way you just whatever you said right now makes me feel you have the handout for previous class. All right, that's a very good one. So let me quickly go into the course objectives. So I'll move on to the next slide. Yeah, so at the end of the class, this whole course, these are some of the things that you would know. Yeah, we would concentrate on 3D and a little of 2D illustrations. 2D will not really create a whole lot of 2D. In previous classes and previous lectures, they did some few things with respect to 2D, but this time round, the concentration is on 3D. So we will create some sort of realistic images, which is based on 3D models. I'll explain all these as we move along. So you will learn the fundamentals of computer graphics algorithm. There are so many algorithms that are available that you can apply to create some objects, or you can call on some of them to help you create these 3D objects. We'll talk about the basics of real-time rendering and also the graphics hardware. By graphics hardware, your normal CPU is unable to do some sort of rendering at a very high speed. So we would need to have GPU, that is a graphic processing unit, to be able to help you create these objects. Now, in the creation of the 3D objects, we will be using computer to do all of this. We will explain as we go along. Now, we will talk about the basic web OpenGL. That is what we will use. Whatever we'll treat here will be the WebGL. Now, the other variant of the WebGL, which is the OpenGL, that one we will use C# and C++, but that is not what we are going to use in here. We will not really talk about DirectX over here as well. So virtually everything that we will do here will be centered on the WebGL. And then by using the WebGL, we have a framework which we call A-frame. That is what you're going to use to create our 3D objects in our scene in the virtual world. So of course, we would not learn OpenGL, but rather WebGL. It's also a variant of OpenGL. So if you have an idea of the WebGL, OpenGL is also okay. So these are ways of talking to the hardware of your computer to be able to generate some 3D objects. We will not talk about DX hacks. We will not be dealing with some already existing software packages that are available to create cartoons. We will not be cartoonizing anything. We will not use, some of you already know of Maya or Autodesk Maya. Blender, I think the first time this course was taught, we used Blender. But along the line, I saw it necessary, since you're a computer science student, it will be best we program or we code to generate these objects. So we stopped the use of Blender. And the use of also Toon Boom Harmony, that is a software that you can use to create 3D objects or images. Mute. Yes, so that's the software that you can also use to create 3D objects in scenes. And we will not also talk about the artistic skills, your artistic skills, or how to do some few other things. We will not design games here. So please have that in mind. As we move along, maybe if along the line you build some sort of interest and will want to create maybe some sort of game design with 3D objects or 3D models of humans, you can use it as your final year project and come and present to us. So that is, this ball is all onto you. You would have to make that choice. Most of the things I'm going to talk about in the course presentation have already been outlined in previous lecture. So we would, there will be a lecture on the VLE, just like what we have here. This is just a general class. We will have a tutorial. There's a practical section. I'll give you a lecture and the handouts that we're going to use. And yes, there will be lots of presentations in this particular lecture. I will teach, I think, about the 4 topics, and I'll give you some few other topics to do it as a group to come and present, which I will award marks for. Lecture periods you already know. All information that you need are on the VLE. These are ways to get in touch with me. Manuel Obu, once again, is going to be my TA for this class. So I would, class rep, maybe today, try and locate him, get in touch with him. He knows he's meeting you guys tomorrow, so get in touch with him. So he knows that you are the people you'll be talking to. Yes, so attendance, obviously, these ones you already know. As I said, I'll be giving you some assignments, which you are to present yourself. You will load it on the VLA, you come and display it to me, just like the web class. You come to me, you display what you have done, and you explain it to me, then I'll award marks. And as I told you earlier, there will be a group chapter presentation. So I'll give you the chapter, give you some time, you prepare, then you come and present. What I've been doing is, because assuming this is chapter 1 that I give you, I will divide it. I'll divide the groups. 2 groups will present maybe chapter 1, so that if one aspect is not being covered by one of the group, the other group would capture it. And of course, during these presentations, I'm going to ask individual students questions, so I want marks too as well. Quizzes, I'm not so sure. I will give you a quiz this time around, but within a semester, if I deem it necessary, we'll have a quiz. It could be a lab practical quiz, or it could be an MCQ quiz, or maybe an assignment, any of those. All right, these policies you already know in previous classes, now let me delve into this. You can see most of the software that we'll be using here are almost the same as what we'll be using in the web programming. And the reason is, with the web programming, because you are learning so many languages, that is one major reason. We are also using the WebGL, so that you will appreciate whatever you learn. So whatever you code in the web, at the end of the day, you can also code using the WebGL, and it makes things easier for students to really comprehend and appreciate what is being taught in the web programming as well. So A-Frame is, as I told you, is a framework that exists. We will use it to do a whole lot of things. We will be adding, changing, we will be creating objects, we'll be adding lights to the scene in the virtual world, we'll be doing some few other things. And the browser, personally, I recommend for this class is Google Chrome. I recommend you use Google Chrome for your browser, because the integration is quite good. Yes, so let's get started. In particular, let's talk about what computer graphics is and where and what it does appear in. Well, the main question sometimes we get when we start computer graphics is, what applications are there when we talk about computer graphics? And I'm very convinced that we all can think of different places where the graphics appear. Most of you fancy movie effects, like those that have watched Avatar, you can see there are lots of movie effects that goes in there. I don't know how it's being called in other native language. In Fanti, we call it awam, you know. It's like they are trying to find a way to make us feel that, you know, this is exactly what happened. By using CGIs, that is the computer generating imagery, it also incorporates computer graphics within it. Most of these movie productions or movie producers, what they do is they have less stunts to display and rather enhance their CGIs to make us feel that these are some of the things that's actually going on. So they have been lying to us almost all the time. I'm sure most of us already know. Unfortunately, the reality is that computer graphics is one of these technologies that is so pervasive. In this sense, it is spreading, and it's wherever you see movies and cartoons and stuff like that, you see all of these coming in. Now let's delve into today's activity. What is computer graphics? Our gentleman gave a very good definition, which is a textbook definition that I'm also going to give you. So computer graphics, what it actually does is it describes any use of a computer to create or manipulate images. And as I said, it's a textbook definition. So anytime you use your computer to create an object, then you are dealing with computer graphics. So this has nothing to do with Photoshop. Photoshop, what you normally use is you have a picture, then you would be dragging the picture around, and editing the picture and doing some few other things. In some way, it would fall a little under computer graphics in a way, but not necessarily in that area. Most of the time, it will be image processing, or you do some few other things in there, but that is not computer graphics. With computer graphics, there should be some sort of way to use the computer itself to create these objects. And by using the computer, you would have to use the GPU of the computer to help you render some of these objects that you do create. As you move along, you realize that it is very necessary you have an idea of what geometry is, because most of these objects that you'll be creating, you should have an idea what geometry is, how to maybe create rectangles or lines or points and the rest. When you have these ideas, you should be able to create these objects out, delve into it as we move along. So you should be mindful that computer graphics is an act of drawing picture lines and charts, etc., and so on the computer screen by using programming language. So you have to use a programming language to create it. C normally talks with our operating system or most of the operating system. So you can also use C to create some of these 3D objects. Most of the graphics that you see in your Windows screen, like the task bar, the environment, the graphics that have been developed, maybe you launch Microsoft Word, you see the interface that you see, these are all computer graphics related. It's the computer that is using to create some of these graphics for you to see and work with your objects or work with products maybe when you are typing and doing some other word processing stuff. So the key phrase here is to create images. And of course, it has to be the computer to do that. So there's a representation of an image of a virtual world of a graphic object from a specific viewpoint. So whatever we create, we know our computer is able to display onto us, like whatever we see here, it's more of a 2D, I will explain it, and there are ways to render it in a way that makes it looks more of a 3D. And of course, computer graphics is related to image processing and computer vision. By computer vision, you know, there are times, there is one professor in KNUST, and he is into computer vision. And in his PhD work, what he did was he created some sort of algorithm that is able to detect a person based on how the person walks. So for instance, if the camera is on the person walking towards us and the face is probably covered, the mannerism and how the person walks and moves with his algorithm is able to dictate that, hey, this is Felix, or this is Emmanuel, or this is Joseph coming. So that relates to computer vision. Image processing, those are the Photoshop fireworks, the photo editing tools that we have. And again, there are other related, closely related fields, which is the interaction HCIs, virtual reality, visualization. So in this case, as it says, interactive. As you proceed, you realize that when you talk of HCI, which is the human-computer interaction, is a way that humans relate or interact with the computer. That's just like, as I said, if I want, assuming there is a button here, when I click on it, it interacts with the computer. So computer graphics relates with HCI as well. VR, by using the VR headsets, you're also able to, those that have played games in the VR, I'm sure some of you would attest to that. Now, you should have this in mind that all computers have graphical user interface. In previous years, the computers that we, like Windows 95 and the rest, before, most of the computers were DOS, most of the things that were being done were in DOS. As they move along, they realize that, well, DOS is faster, but it's not everybody who has an idea of how to use some of these DOS applications. So we have to find a way to incorporate a graphical user interface that makes people who are novice to the use of the command line to be able to click, add and drop, and do some few other things. That is how most of the current computers are into. So virtually all the current computers have a graphical user interface. And most of them are 2D, and we have some of them being having 3D effects. We'll talk about this as we move along. Now I have an image in here, and I will want Bridget to help me. On the left side, Bridget, and I say it here. I would want you to help me answer this question. Now on the left side, that is this side, you can see these are 2D and 3D objects. Now on the left side, Bridget, do you see anything that probably should not fall within that category, but is that category? Do you see any objects in the left category that probably should be in the right category?
Sir.
Yes, Bridget.
Sir, please.
Just look at it critically. We have triangles, we have rectangles, circles, cubes, pentagon, and the rest. And these are all 3D objects. There is one which is not these are all 2D objects, but one does not fall in the 2D objects category. Can you spell out or let me know exactly which one that is?
Sir.
Yes.
Please. The cube.
Okay, so why do you say it's the cube? Can you tell me a reason why? Why do you choose the cube?
Sir.
Yes.
Please, it has the 3 dimensions.
Okay, so by saying that, can you distinguish between, this question goes to a different person. Shadrach, Asabia, hey, is that how you spell Asabia? Oh, yours is not Asabia.
Yes, sir.
So it's Asabia. Oh?
Yes, sir.
Okay, Shadrach. So can you distinguish between what a 2D object and what a 3D object is?
Sir, 2D objects usually have 2
dimensions, let's just say length and width or something, and then 3D usually have
Don't say on something.
dimensions.
You have to be specific.
Specific.
I don't say or something. So please.
Okay, so 2D objects usually have 2 dimensions, say maybe length and width, whilst 3D objects usually have maybe 3 dimensions, like length, width, and height. That's in the case of cubes and maybe rectangles or something.
Great. So in a general sense, what letters do we denote 2D and 3D objects? Okay, what axis or what letters do we normally denote them with? In a general sense.
I don't get you. I didn't get your question, sir.
In a general sense, for 2D objects, we normally denote it with, on the Cartesian plane, that is, let me put it that way.
Okay, sir. 2D X and Y axis, 3D X, Y, and Z axis.
Exactly, right. That is very good. Thank you very much, Asabia. And
you're welcome, sir.
A good point made. Yes, so now, as Asabia and Bridget said, this obviously has the height to it, which is the z-axis or the z-axis, so it does not fall within this category. Apart from that, any of these are normal planes that have x and y. On the right side, we have the cone, cylinder, and the rest, so they are 3D objects. All right, so on this side, you can see we have some sort of reflection coming in here. So the objects that we create in the virtual world, we would add light to it. Lighting is very important when it comes to 3D object creation. And that is what makes our computer looks more like we are actually viewing a 3D object, because lighting gives us shadows and adds based on the intensity where the light is incident on the objects. It makes us appreciate the kind of object that we have. I think I have some few questions here. Hey, I'm told tomorrow is a holiday. Oh no.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
We can close it right now.
I'm going to chill. You are invited.
Oh no. Can we have the class rep here? Is the class rep here?
I said tomorrow.
Who is the assistant class rep?
I think they are not around, man.
Okay. Oh.
Sir, please. Actually, the holiday is not yet confirmed.
Okay. So, but let me say this. In fact, it would be best we try this course. There is a lot to learn, especially the web. So the more time we have, the better for all of us. With the graphics, that is fine. We can always find ways around it. And of course, I already have videos of how to create these objects online, which I think I've activated. Yeah, Jacob, you're back. Yeah.
The server setup. The setup. Yeah.
Yes,
so let's finish the class tomorrow.
Yes, hold on. Let's hear Jacob up. Yes.
No.
I tried
tomorrow.
The installation of the PHP and then my admin, but the local host doesn't respond.
Don't worry. Anybody who has an issue can see me personally or see the team. But you don't have to install them one by one. Just install some, and that is all. If you have issues,
I did the one installation, but it doesn't pick.
That is fine. Don't worry. We would have solutions to that.
Okay,
there might be a port which is using the port 80 and 443. That is fine.
I installed the the Joomla and then the WordPress. So I think one of them has taken over.
Oh, not necessarily. When you use Joomla, when you use Joomla and when you use WordPress, you don't need, none of them would have will have with the others. This is not a web class, so don't worry. You can see me later. We can move on.
Okay, sir.
All right. So And of course, yes, you remember when I was going through the software, we are going to use WAMP or XAMPP this time around to it again. It's very imperative for this course too as well, for web graphics, WebGL. All right, so maybe as we move along, we'll still talk about the holiday again. But in the meantime, let's proceed. All right, so now I believe most of you have this in mind and have an idea where computer graphics and special effects really work in the movie industry. Now let's go over some few examples. So generally you can see when we talk of computer graphics, what usually comes to mind for most of us is the movie industry. And of course, there is both animated films and those that come with Pixar, that is the DreamWorks films. And so many things happening in the blockbuster movie industry. So on the right side, you can see this is what is happening. You can, I don't know, this is Shrek, right? I don't know. This cartoon, I think most of you must have this. Yes. And this is Spider-Man. Funny enough, you see, most of these movie producers, they have this, you can see that there is a green screen. And by using a green screen, it makes it easier for them to remove the background and put any background behind the scene for people to feel they are actually, you know, whatever they are watching is the main thing that is happening. So from here you can see he is on he is on a chair, but behind the scene, because he has a green screen, they remove this and put any background in there to make him feel it's probably somewhere. Finding Nemo, that is a movie I watched some years back. I don't know if any of you have watched it. Matrix, you see, when you look at it, of course, there's a green screen. Yeah, Finding Nemo, I'm sure some of you might have watched it. It's nice. So Matrix also have a green screen with these cables attached to all of them, and them being spinning around. But in actual fact, this is how it looks, but in the movie environment, this is how it looks. I mean, I remember I enjoyed this movie very well. I think this is the Reloaded. Looking at this one too. In fact, in the movie world, they have been lying to us almost all the time. This movie, which one is this? This movie, Game of Thrones. Yes, so this one is Avatar. So these are ways that they use CGIs, you know, to come out with very nice visual effects for us to appreciate. Now, computer graphics is being, in fact, you see it in so many environments. We will talk about of these, talk about them as we move along. I have a short video which I'm going to show you now. So I would want us to just take some few minutes to go through to check this out. Okay, so all right, so Stargate has a lot of these videos online. So those that would want to view them, you can always check them out. Let me put up this so we can continue. Right. Yeah, so the movie effects aren't the only place that we see computer graphics technology. There are other places like the video games. Grand Theft Auto, I don't know if it's still Grand Theft Auto. This game is very interesting. I remember I was so glued to it some years back. And this is Mario. These are all computer graphics games, related games that have been created. I think this is Hitman. That's a very nice, okay, this is Hitman. I think this is the same as this one. Very nice game that you can play. Now, nowadays, I'm sure most of you are aware that there are times those that have gone to driving school before, this time around, you can just walk into the driving school, some of them have simulators or simulations of how to drive. You'll usually have a very big screen and a prototype of, Olivia. We have a very big screen with a prototype of maybe how to change the gears of a car. I'm sure most of you have seen that one. So you can learn how to drive without even hitting the road. So all the practicals are being done in the simulator before you finally go or hit on the road. So video games and movies are not the end of the story. Those are probably the two most obvious examples of computer graphics technology, but there are so many more. So for example, another popular application of graphics in a 3D world is a simulation. So here, you guys will see 3 scenes, screenshots from a brand new flight simulator from Microsoft. So this is what you see, those that would want to check it out. So it's a flight simulator. And within it, you have the chance to see the dashboard of the aircraft or airplane. And there you can see there is a runway somewhere in here. Let me bring this one here. There's a runway in here. So it's simulated in a way that you probably would be wearing your headgear, and that will put you in a 3D environment. So you feel that you are actually in a flight, you are in the plane and learning or probably driving the plane. So there are so many absolutely stunning and also beautiful things that most of these developers are able to do when it comes to simulation. But you'll be mindful that most of these people are always put in a virtual environment to test out most of these technologies before they go onto the real world to fly the plane. And of course, what do you think is a very good importance for simulating some of these objects in the virtual world for people to learn before they actually do the main thing? Can anybody tell me?
It can prevent accidents since it prevents accidents since the trainer doesn't have enough skills to fly the aircraft.
That is a very good point, mate. Who was that?
Please, George.
George. That's a very good point you just made.
George,
can anybody also give me a reason why it's best to have a simulation of some of these real world practice environments before we actually come to the virtual world comes to the real world? Yes.
Please, it's quite real to real life experience since you got a feel of what you are going to actually do on the field. So I think that's why simulations are very important. Sometimes it's even used to test situations that, actual people experience. Like when there was an accident and you could have saved it and you didn't save the accident. We can use the simulation to test that in your circumstances could you have done anything that you didn't do? I saw that in one of a movie, movie called Sully.
I think I've watched that movie. That is a very good point.
Yeah, Sully.
Yes. Yeah. Gideon, you are actually right. I agree with you. Can anybody give me another reason why? Yes, Samuel, Solomon?
So to reduce the risk involved.
Okay, yes, indeed. Accident risk, that is true. Can anybody also give me, yes, Joe?
Sir, please, to identify glitches in the software. Yeah.
Software. Can you elaborate on that a little, please?
So maybe if you're supposed to apply a break and then it speeds up the how do I call it? The thing being tested, you could identify that, okay, you were supposed to actually do this particular
thing. That is a very good point, but I rather will put that one under CAD and CAM. So we'll talk about it, I think, in the next slide. But it's a very good point.
Show the confidence level.
Okay. Yes. Kenneth? Yes.
So I'm saying also build the confidence level of the learner.
Wonderful. That is also very true. There is something I really want someone to spill out. I've still not heard it. Joe, do you still have your hands up, or I can put it down? Anyone? Let's take the plane analogy as an example. We have a simulation of the plane, and people now learn how to fly the plane. But in the real world, there is another reason why it will be best to get it simulated and learn from the simulation before you hit the main runway. There's another reason. All the points you've raised, they are wonderful. But there is one thing that I'm looking out for. Yes, Jacob?
It saves money if in case of accidents or something.
Come again?
It saves money in case of accident or anything. The product or the thing that you are using cannot be affected.
That is indeed, yeah. That is a very good point. Economically, apart from building, and these are software-based things. We have the developers building a software to help in the simulation, and at the end of the day, it does save money when you have this simulated. You can have so many people. You have the software already built. You have so many people learning how to fly the plane on the same software. If it is network, even better. So you can have thousands of people being interacting with the simulation at a go. One more thing, just imagine if you are to learn how to fly a plane, look at the fuel that will go into a plane in just learning and going up, to fly. But with a simulated environment, you don't really think much about the fuel you will burn for this long periods before the actual real world practice come in. So it's a very good point. So economically, it is good. The only thing that would be an issue is the first time that the software is being produced. But of course, most of the time it's organizations that put up these software to help people learn. So it's a very good point. In the simulation, yes, so economically, it also reduces costs, yes. So when we talk of CAD and CAM, CAD stands for computer-aided design, and CAM also stands for computer-aided manufacturing. In fact, these two things go hand in hand, and they looking at the picture that we have in here, as I think one of you mentioned, I don't know if it was Joe, to see the manufacturing defects, if there are issues with maybe this product, for instance, it is being simulated in a way that at the end of the day, the user will wrap his finger across the side and uses, I think, his index finger to press this one. So it could be simulated in a way to see the manufacturing defects. And if there are issues, now they delve into it, correct it, make sure this is how it's supposed to be. And most of these companies or organizations into the building of products, like let's take this watch too, for instance, they are able to have a 3D design of the watch before they actually manufacture the watch. Those of us who have been buying things online, especially on AliExpress or Alibaba, most of you will confirm with me that the product design that is being displayed over there, if you should, the design that is being put on AliExpress or Alibaba, when you make the purchase, when you get the actual product in real life and you compare it with it, you can see there is a little difference. I don't know if most of you get my point. Sometimes you can see the picture actually looks so beautiful, but the object itself does not look as beautiful as the object that had been simulated or that has been designed. And those are all prototypes. But of course, you have a real idea of a general idea of how the product will come out. Now, the bicycle, for instance, you can see this is a different type of bicycle that they are having. So the computer-aided design can help you build this one, test it, run it on the computer to see how each part would work before the actual product is also designed. Computer-aided design and computer-aided manufacturing, which is CAD-CAM, is a combination of two terms, CAD and CAM, to describe the software that is used to design and manufacture prototypes, the finished products, and also the products as the product runs. Now, looking at this one, you can see this is a building. The architect did not just design it. You see how sophisticated and how complicated this building really looks like. So just imagine on the first run, they don't simulate it. They don't have a 3D model of this building, and the contractor just walks in and start constructing. Along the line, there's a high probability that there will be a physical, a structural issues with this. Because if he misses possibly this particular pole, if he misses this pole, there's a high probability this whole thing would collapse. Or, in fact, it is always best to get all these simulated, see how it works, and make sure things are in order before they finally hit the ground to construct an edifice like this one. You can see there is so much money going into this, so you can't give room for making mistakes. All right, so this building is expensive. It is best to have the graphics person, get a very good simulated design of this one based on the architect's design. All right, so that is an example of in architecture. So this is an example where computer graphics can also be used. Now, in interior design, you can see how this room looks so perfect. And mind you, most of the objects or the scenes that are being created in a 3D virtual world always have, in fact, some sort of perfection. The objects are always perfect. But of course, in real world, we can't have that perfection. So the ways to really notice that maybe a picture or a model is actually the real world thing. The real world thing would have some sort of, it will not be perfect in terms of the color shading. You can see that there is a light coming into this, but in the real world, there might be a little glitch and all of that. So there is perfection with objects and scenes that are being created in the virtual world using computer graphics. So preview of the previous building, and these are the interior designs. So there are times those that are into interior decor, they can have, or somebody builds his house, how to even position some of the objects needs to be done by somebody who is an interior decor expert. So he knows the bookshelf probably should be here, the TV should be here. So he can simulate all these in the virtual world on his phone or maybe on a tablet and show the client if the client is interested before the final interior decoration is being done. All right, so that saves time, of course, and that also saves money. All right, so these are all examples of pictures that were being done with computer graphics. It is very probable, like the scenes, in fact, in previous classes, I've seen students coming out with wonderful designs, and I expect to see beautiful designs as well in this class as well. So please, let's take our practicals very serious and let's enjoy the class together. All right, so these are objects that were designed using computer graphics. So this is also an office. It looks so perfect. The lighting, the shadow casting, and all these. Now, in another area that computer graphics also works is in the virtual reality, where we have the Google Card or maybe the Google Fabric VR headset. So as we talked about the simulation, most of the simulated devices you would wear maybe the headset or headgear to be able to interact. Those that have played games that are 3D, they will always have the headset on or headgear on, the VR headgear on, be able to play some of these games. There are times you see people even playing lawn tennis with the headgear, with the computer, with the TV in a way. So these are all examples of where computer graphics is being used, virtual reality. Yes, the objects that we would create here in the 3D scene or environment or the virtual world, in fact, those that have, like the Google Card, for instance, cardboard, this one, or they have VR headsets, you can also view the object. In fact, the scene that we will create in this class, if you should put that your phone within, like just like this one, you put it in there and you try to visualize it. It should look like you are also in a 3D environment and you appreciate your environment. Don't worry, we would import and do some scene creation and all of that. You get to appreciate these. In the area of virtualization, virtualization is any technique for creating images and also diagrams or animations to be able to communicate a message. So there are times our chemistry teachers try to explain the atoms to us and how these atoms come together to probably form water. So they probably show us using some of these modules to help explain things to us better. Looking at the graph, you can see this is a virtualization technique that has been used to create this particular image so that we're able to, this is able to communicate to us something. During the COVID time, you realize some of you might have seen this, and from here, you can, from what we see in here, the cases or the legend that is displayed here, the further you are away from the color yellow, you move into red. So the red denoted countries that had a huge number of people with COVID. So when we talk of virtualization, it's a technique that we normally use to create images or diagrams or some sort of animation to be able to communicate this. So looking at this, that is how it looks like. And there are a lot of, when we talk of virtualization, there are so many ways available. So we can also have a data virtualization. So in this case, we have some numbers in here. I think this is a part of my work, my PhD work. So the normal graphs that you do see here. Jacob, do you have a question?
Sir, I wanted to ask if this data visualization was by a program, like maybe a programming language, Python or something.
Okay, right, that's a good point. Yes, so with data visualization, the good thing is Python has a lot of libraries that you can use to visualize data. Python is a very good programming language which you can use to do that. There are some libraries that you can call. Apart from Python, the regular Excel, Microsoft Excel that we all know, can also help visualize our data. So in your introduction to computer science and engineering, when you did Excel, if you recall, you probably had two columns, column X and column Y, with X values and Y values. And you were able to create a virtualized graph. Maybe it could be a bar chart or a pie chart or column charts. Based on the data in X column and Y, you are able to probably generate an equation of a line. I'm sure you remember you did something like that. So that is part of data visualization. So data visualization is a process of turning your data, which is the X and Y values that you have, if it's equation of a line, into graphical representation that can communicate logical relationships and also lead more information whenever you want to come out with it, to make decision of the data that is being explained to you. So in actual fact, I will be able to explain this, but you will not understand. I would have explained, of course, maybe some of you will know. You can see we have accuracy and also false alarm rates. So the red depicts the false alarm rate as you progress from any of these algorithms. We have naive Bayes algorithm, we have the k-nearest mean decision tree. All these are algorithms that we use in data science or machine learning. So when you have enough data, you'll be able to visualize that particular data in the form of a graph, a bar chart, a stack bar chart. In fact, there are lots of these types of data visualization charts that are available. And all these, even pie chart is a data visualization chart or graph. So in the medical field too, we have something we call medical imaging, and this refers to a technique or process which is used to create images of various parts of the body for diagnostic and also treatment within a digital health. So for instance, there are times maybe you have an issue with your lungs, maybe you're coughing like how I just coughed. The doctor tells me, go and take an x-ray. Last week we missed the class because I had to go to the hospital. Not me anyway, my son had a little issue. So in that case, you will be told to go to the lab and take an x-ray. So an x-ray is an example of a medical imagery technique that is used to actually see exactly what is happening within the internal organs that we have in our body. So it's a technique, a process which is used to create images of various parts of the human body. So with that, you're able to see your ribs and the lungs, maybe portions of your lungs. If you've swallowed a coin, it's able to detect that this is a coin is within your stomach and the rest. So the term medical imaging includes various radiological image techniques. And as I've given you, an X-ray is one of them. We have the magnetic resonance imaging, which is the MRI. Those that have, I don't know if any of you have gone into an MRI. This is an MRI. If you watch a movie, you see an individual being pushed into a round circle to probably find out what is happening in the person's brain activity, like how you see over here. So in the medical field, medical imaging is, and these are all graphic stuff. So, and you use a computer to generate these objects. So that is where computer graphics also falls in. In educational environments, I need not really explain much here. We use it in teaching, and learning is now done at home, like where right now you are on the comfort of your bed, wherever you are, you're listening to me whilst I teach. And these are all possible because of computer graphics. And the reason is being able to even see your computer screen and know exactly what I'm teaching. That is a graphical user interface aspect of a computer. Also falls within the computer graphics. So you'll be at home and I'm able to lecture to you and explain certain things to you. So in the educational field, computer graphics is also being used. There are times, maybe if I want to teach something and I need to get it visualized in the form of objects, computer graphics could be made and simulated for students to also see. In the area of geographic information system, which is the GPS, if you recall, most those that drive around, maybe you want to go to a place that you have not been before. The good thing is Google has come up with their Google Map and also Google Map, where you can just input your current location and the destination location, and it's automatically draws. You can see it will draw the map and give you the path to choose, the shortest possible path to choose to get to your destination. So in the area of GPS, graphics also does work. Yes, so that is about GPS. So I spoke about any of these displays. That's the human-computer interaction, which is a discipline, multidisciplinary field of study focusing mainly on the design of computer technologies, which will aid in individuals interacting with computers. So computer use OpenGL and DirectX to display almost anything on the computer. So virtually, if you recall, I was saying C programming language is one of the basic languages that helps talk to our computer in the creation of some of our operating system. So most of the things that we do, we have the OpenGL helping us to display some of these graphics for us. And the good thing is with WebGL, we have our browser also talking to a GPU to help generate some of these objects for us to see. So this, we have the 2D objects. We also have Illustrator, PowerPoint. In fact, virtually all the programs that you have running on your computer, once it has a graphical user interface, it has something to do with computer graphics. So we are all of us, we are surrounded by screens, phones, laptops, and the rest. George is saying WhatsApp. What is WhatsApp, please? Can you help me understand? I don't get it anyway. All right, so now Pixar, I mentioned Pixar earlier on. So Pixar, some time back, this is how Pixar was going through to get some of us, the Pixar movies for us to see. So, of course, I gave a reference to this. This website might be outdated now. You might not see this, but this is some information. And this is the timeline, how they do these animated movies. So this is the Pixar process, how to make a movie, the things that they go through to come out with that animation. So the first is they are able to, you first of all will have to get an idea. You pitch the idea to see if indeed it's going to come out as a very good story. So you can see the individual, putting things together, thinking about it, how to get things done. And the second is a text treatment, which is written. So the story, you have an idea, you think the idea is good, people will enjoy it, then you get it written down. Once the story is written down, then we have people having it typed already. I think I missed one particular step. So once the story has been typed down correctly and written, we move on to the fourth one. The third one, you get it written and typed down, given to the right people who will be talking, doing the voice over. So we have the voice talent begins recording. So those that are very good with talking voice over of cartoons, then they begin doing their recording in terms of how the characters are going to talk in the scene that will come in. Eventually, they will put all of them together. So the editorial board also begins making some reels. In fact, I'm giving you this so you can read more on this. I don't want to spend much here. So with the fifth one, the arts department creates the look of the objects or the models that that would be in the scene. So in this example, you can see you probably have a dinosaur and this funny looking individual with one eye. Then the models are sculptured and also articulated within the scene. So if you recall, I was telling you about something about geometry. In fact, mathematics is very key whenever we talk about computer graphics. Different lecturers have different ways of teaching computer graphics. Some will teach it with linear algebra in mind, linear algebra in mind with some sort of physics. Of course, if you create an object and you incident light on this particular object, you expect to see the object casting a shadow on the ground or on the surface of where the object resides. So physics and mathematics is very key. There are times I would expect students, in fact, we'll be doing some small calculations and the rest. But the good thing is using A-frame, all these things are incorporated. So you just have to have a little knowledge of linear algebra where to be able to come out with photorealistic images or objects that will be created in the class. So in geometry, I was talking about geometry, you can see these, this is more like a mesh of the character, which is supposed to be produced. This particular, maybe the character will come in. So we have a character, so we have a geometry being constructed of the character. And mind you, as I said, in computer graphics, this is the creation of these objects by the computer. You don't draw it. You have to use a computer to create it. And in creating it, you need very good high processing power to be able to render the objects that you create eventually. So from here, you can see we are using geometry to come out with this one, this particular object. So we have, you can see there's a mesh of the character. These are mesh, more like lines, drawing plenty lines. As you move on, you realize that there's some things we call primitive. I'll talk about them. So Pixar will also make sure the sets are dressed, the thing that will go on the sets is ready, the shots are laid out correctly, and the shots is then animated in a way. In previous times, you know, when people will want to animate something, some of you might have seen, you'll see the artist will probably draw, maybe if he wants to run away, he draws the character with probably the hand right like this. The next time the hand coming down on different sheets of paper. So he probably has about 100 papers together, and each of the paper has an individual picture of an action that the object is supposed to do. So at the end of the day, he picks the object, then he finds a way to flip the object in such a way that it looks like the object is moving. So those time back, that is how they were able to do the animation. In the same way, when we do animation using software like Blender, you are able to get individual layers of this particular character to be able to appreciate the movement of the character. So at each frame, there is some sort of little movement of the character. So that is how it has been for this one as well. So these are old ways of doing things. The sets and the characters are also shaded. We'll talk about shading, adding textures around the object. If you have maybe adding color onto the object, that is shading. By adding materials onto it, if you want to clothe the object, you can add materials also onto it. In fact, we will talk about all of these as we move on. I told you lighting is very important when you talk of computer graphics. So it is lighting. If you don't have lighting in your scene, the objects in the scene does not look realistic. It is light that makes things look so realistic. So you have to find a way to give lighting, to add light to your scene to make your scene look so realistic. All right, so the computer data is also rendered. So at the end of the day, you need to render it. That is where the GPU will come in our environment. CPU can also render, but it will do that at a very low speed. Those that are into Bitcoin, you realize that, I'm sure you might have heard that, the coin needs, there is a huge algorithm that needs to be calculated by your machine to be able to mine Bitcoin. So in doing that, you need very huge GPUs, not CPU. CPU can do that, but it will take, if a CPU is taking maybe 100 days to complete maybe one render or computation of the Bitcoin algorithm, then GPU can do it possibly within a day. So GPU are very powerful when it comes to rendering of graphic objects. So the final touches is done at the end of the day, then we have the scene. So you can see modeling in here. We have animating, we have shading, we have lighting all put together. So graphics creates an image of a virtual world of a graphic object from a specific view on a graphic design. We will talk about what a raster display is. We'll give the differences between them. So when we talk of modeling, modeling is a mathematical specification of the shapes and the appearance of the objects that will be placed in the scene. Rendering is the creation of shaded images from 3D computer models. And finally, animation, as you know, creates some sort of illusion of motion through a sequence of image. So with the paper that I showed you, so that is how animation is. And of course, there are software like a movie, like the short movie. If you have a short movie and you want to see each of the frame, the movie is more like a series of images which are placed in sequence, probably with a voice over. So there are some software that you can, if you have about a 10 seconds movie, you can use the software to break each of the, to break the movie file into pictures. So at the end of the day, you can roll the pictures and it will look more like it's a movie because it is there's some sort of transition from one point to the other. So in movies is just picture in motion. Let me put it that way. That is how movies are, with probably a voice over behind. So so how can this picture be made? So you can see this one, it looks too perfect with the right lightning and some few other things. So how can we model and compose, eventually draw and display the scene like the one that you see here? So we can use computer graphics to create an object, a scene like this. And this looks more like a computer game. So we have the modeling, as I spoke to you, we'll be dealing with the geometry, the materials, the lighting. The animation will deal with how to make whatever we've designed move. And the rendering is the process of drawing a scene on the computer. And by rendering, we can have to draw a picture and put in some lighting in there. So what exactly is computer graphics now? You've learned some few other things. So you can see this is an object. This is how it looks like when it started with the modeling. By modeling the objects, we have to get the geometry of the objects. And by the geometry, that is when we use lines to get, in fact, we are using a computer to do all of this. We use a computer to get all these drawn. And the next step, we'll have it in this way. That is where we add color to it, textures and the rest. At the end of the day, we add our material over here and add lighting. And that is what makes this particular object look so real to us. So there are two main approaches that computer graphics. Yes, Prince, do you have a question? Okay, so there are two ways. Okay, so there are two ways that approaches that people, most lecturers teach computer graphics. So these are the two approaches. We have the basic and the background. You should have some sort of knowledge in physics and mathematics, as I spoke to you. And so most lecturers will either delve into this one or use some sort of application or libraries to create your objects. Unfortunately, we will not be using an application, as I spoke to you about, like Maya, like what do you call it, Blender. We are not using such applications to create. We are going to code our objects to create them. So based on physics, the physics of light and mathematics, geometry, we will be able to create our objects. Okay. So what we're going to learn here will be modeling, transformation, animation, ray casting, ray tracing, ray acceleration, all these. So ray casting or ray tracing gives a very high quality rendering. By rendering, that is, after you've done everything, you need to render the object to make it look more realistic. Unfortunately, when we ray cast or we ray trace, it's a very slow method. So it is slow, but at the end of the day, patience is golden. So if you are patient, because it's slow, eventually it's going to come out with a very good photorealistic image. They are normally built on the physics of light that bounce on the objects in the scene. So we have the real-time graphic pipeline, which is fast, and it uses to draw the content on the scene at a frame rate that is acceptable for interaction. So there are basic methods for image generation. So we have the two basic methods. We have the ray tracing and ray casting, ray tracing, ray casting, and we have the projective methods. These two methods are the ones that we normally use to generate our objects in the 3D world on the scene. Now, let's talk about the first one, which is ray casting or ray tracing. So let's take this as an example. So with ray casting, so we have for every pixel, so it deals with pixels. So assuming we have an object here, which is in a 3D world, this object is in the 3D world. And now if we want to, objects in a 3D world, we have to find a way to bring them onto the screen for us to see these objects. So for instance, we have a round ball here, which we want it to be on the scene. So the observer will probably be here with his eye here. So a ray is cast from the observer's eye through your computer screen to the object which is there. So now we have to find a way to project the color or the pixel that the ray hits in the 3D world onto the scene over here. So at the end of the day, you would have it's because it is pixel based, the color of the object in the 3D world is what is displayed on the scene. So if it is red, eventually it will come out as red. Now, if we have another color, let's say blue, over here, that is between the 3D world and the screen of your computer, then assuming this is blue, then it means our ray will pass through, let's say it's a transparent blue. If it's an opaque blue, it means our ray will not be able to penetrate through the blue color. So the object, the picture that will be displayed on the scene would be blue and not red. But if it is transparent objects are objects that have the tendency of light passing through them. So in that case, it will take a little portion of the blue transparent color and merge it with this to produce a different color, which will be here. So that is how ray tracing is. So when we talk of ray tracing or ray casting, we normally deal with pixels. So we construct this, we construct a ray from the eye for each of the objects in the scene. We find the intersection of the ray and we keep it to the closest. So for instance, if you have this one too, the object will be the pixel over here on the screen is what is going to be displayed over here. Now you should be mindful that if you take a picture, somebody sends you a picture onto your phone, and you try to zoom the picture in, or you stretch the picture, it gets to a point the picture pixelates. By pixelating, you get to see each fragment of the picture. You see some pixels of the picture. That is what you mean by pixelation. And by saying this, objects, that is why we're saying that if you take a picture right now, if I take a picture of myself and I stretch it, it gets to a point it pixelates. So that is raster image. Now for vector images, these images do not pixelate. So an example For vector images are images which normally we use our computer to create set image. So if we use our computer to create maybe a cube in a virtual world which is displayed on our screen, we'll realize that the cube can be stretched to a very high dimension. We can increase the size of a cube to a very high dimension, and we will still not see a pixel of the cube. It's because it's a vector image. So that is about the raster images and vector images. Raster images always pixelate whenever it is being stretched, and it is not the computer that does the creation. But with vector images, when you stretch it, the images will definitely not pixelate. So software like Illustrator, for instance, usually does not pixelate. Or Microsoft Word, if you type A and you increase the fonts so many times, do you see the pixels of the letter A? No, it's because it is the A is being it's on the screen because it's the computer that has created that A. So these are vector images. So that is about ray tracing. Ray tracing can also actually give a very good picture. So we have shading. So in this case, we have an interaction of light and material. So if we incidence light on this particular side, and the light has a different color, of course, it will have some sort of issues. It will have some way of changing the color of this particular object. Now, all these are done and computed in a way by the algorithm to help display it on the scene. You should be mindful that the screen that you are watching me from now, it is a 2D screen. It is not 3D. So how are we able to see things in a 3D environment? So it's the lighting aspect of it that makes us feel. So for instance, let me go to the next slide, you can see, when you see, immediately you see this object, sorry, immediately you see these objects, you see that it's a 3D object. But the screen that you are using to view this object is a 2D screen. It's a 2D screen, it is not 3D. So how are we able to do this is because of the effect of light that helps us actually appreciate these objects to be 3D. In actual fact, our screen only gives us objects in 2D. Because of the lightning that we put in there, it always makes us feel that indeed the object that we have created is a 3D object. So for shading, we interaction of light and materials, secondary rays. So we have the shadow, reflection, and refraction. That is where phases come in here. So for photorealistic rendering, usually ray tracing algorithms are used for every pixel. So that's how come you have to pick up each of the pixels and put it on the screen for us to see. So at the corners with the light, if it is red here, and getting to the corners, it might be a little darker red. So that is what makes us feel that indeed we are viewing a 3D object. So it computes rays from the viewpoints through the pixel center. It determines the intersection points with the first object, which is here. And when it hits it, it does the calculation of the shading for the pixel, possibly with some sort of recursion. So that is about ray tracing, the basic image method for generating images. So generally, with ray tracing, we have some sort of global illumination. You have lights coming from every source. And usually it is very slow. It's a traditional way of doing things, but it comes out with very perfect pictures. So recent developments, we have real-time ray tracing. So these objects were created using ray tracing. Yes, so moving on. So these are objects that have been created using ray tracing or ray casting. So this is an example of an object that is ray tracing. There's also another example. These are all examples that were ray traced. Now I have a question here. Briefly explain how computer graphics is integrated in the following areas. human-computer interaction, information virtualization, and image, medical imagery. I will advise you read around this. I've spoken about them, but I would want you to also have an idea, at least read around it yourself. I'm not going to take any assignment. This is not an assignment, it's a question I just have for you. For the projective method, are these objects also displayed on the scene, on the screen for us? So we have a 2D object or a 3D object in the scene, which we want it to be on the screen of our 2D object. So a popular method for generating images for 3D models is projection. So you have a 3D triangle, which eventually will be projected to a 2D triangle on our screen. So the first thing is we have our eye sending, so this is the observer, and this is the eye of the observer. So rays are being sent from the eye of the observer to the vertex of the objects in the 3D world. And each of these, so first of all, the vertices for projecting method, will have, it deals with the vertices. So it will pick the vertex and will bring it to the screen so all the vertices are put on the screen. And at the end of the day, it fills or shades based on the color that is already there. That is how the projective method works. So you should notice that ray tracing is equal to pixel based, and projective method is also related to object based. So with that said, so that is how the projective methods is. So it's used by OpenGL, DirectX, and related shaded languages. It is very fast compared to the ray tracing, and it's hardware supported. Real-time applications is normally used in games and the rest. These are examples of things that have been done that you can model with projective method. Don't worry, some of these things there are a lot of models that we can always include in our scene. So we'll talk about them as we go along. Now we have what we call the graphic pipeline. So it describes a process of going from the 3D, let me put it here. If you remember, I was talking about this is the 3D. Objects in the virtual world will be in a 3D, but it can only be displayed in a 2D, in our 2D screen, which is our monitor. So the objects will probably be in a 3D, but it eventually will be in a 2D screen. It's based on the lighting effect, we will have it on a 2D scene. So the graphic pipeline describes the process of going from a 3D representation, which is in the abstract world of our scene, to a 2D representation of our screen. So in this case, we would have a geometric description of our scene to a pixel. So at the end of the day, on our screen, eventually our screen will give us an object which will be formed in form of pixels, which I talked about. And these are the processes that we go through. The 3D graphic pipeline is a special hardware or software subsystem that effectively draws 3D primitives into perspective. The sequence of operation transforming 3D models into the pixels on the screen. I keep saying that our screen can only display things that are 2D, but because of the lighting effect, it makes us visualize it more like a 3D. So the objects are always in the virtual abstract world, and eventually they are displayed on our scene through that. So for the application, we have, first of all, we compute a 3D geometry, and we make calls to graphic APIs. You know what APIs are, application programming or program interface. And there are lots of APIs that are available. Most of these APIs usually support certain primitives. And the primitives could be in the form of a triangle or a full stop. So every programming language has its, every programming any of these APIs have their own primitive. Some of them, OpenGL will probably have a primitive which is triangles. WebGL will probably have a primitive which is lines. Others could be full stops and the rest. So if I want to draw maybe a human being, I can draw so many lines. So in this case, the basic form of object that I can draw is a line using that geometry. I can create so many lines to come out with a mesh like how I showed you of a mesh of that particular animal. So drawing all these lines using the computer. So these, in that case, a line could be a primitive. So that is what could be done. So if I want to draw a circle, I can have maybe a primitive of a triangle. So for instance, if I want to draw maybe a circle, I can have, and if the API I'm using has a primitive of a triangle, I can have one triangle drawn, another triangle drawn, another triangle drawn. So we can have so many triangles coming together to form a circle. So that is a primitive. If it's a line, it can have a line drawn, so many of them. So in graphics, an example of these, we have the DirectX 3D OpenGL with shader language, HL, SL shader language, the high-level shader language. But we are not using these particular one in our own. So OpenGL shader language code to it's a Microsoft high-level shader language. Where shading language usually is a graphics programming language which adopts, usually is adopted by programming shader effects for characterizing interfaces and volumes and objects. So some of these languages usually consist of special data like color and normal stuff, but we will not be dealing with some of these. So from the application layer, we come to the vertex processing. I explained using the projective method as you saw. So at the vertex processing, we have the transformation of the geometry from the 3D world to the 2D scene, to the 2D screen. So in the 3D world, we keep talking about scene, and on the 2D world, we talk about screens. So that is about the vertex processing. Then rasterization is when we have, we move from 2D geometry to fragments. So at the 2D geometry, we can have, you can see as we did the projection from the 3D world, the vertex processing, we have it here like this. So because of the image that we create will be rasterized, you can see the point is in the middle of this box. So it is these points that will color. So that is how we'll see the objects. We'll see the objects rasterized on our screen like this one. So that is about rasterization. So we have fragment processing and blending. So these are the steps that involves. We process the fragments by putting in shading and texturing and by combining fragments to the final pixel. So at the blending, so we should also note that with shading, shading can be done in different stages. So at each particular stage, you can do shading by adding pictures, by adding materials or colors to our objects. So we will look at almost all of these in the next lectures that we'll go through, and when we start with our iframes. So you should have an idea. You can read about what the graphic